few years ago, Ubiwhere started developing solutions for smart cities, focusing on solving concrete problems for specific city verticals related to mobility, such as bike sharing, parking or traffic, and environment, such as air quality or waste management. These solutions help cities become more sustainable by improving the efficiency of such verticals through the introduction of different types of devices that can collect data in real time. One example are parking sensors that monitor parking spot availability and communicate that data with a central platform where citizens can check for the availability and managers can analyze how different areas are being used. However, from an early stage, we realized there was an even bigger opportunity in having a single platform where the key decision makers in a city could have a holistic view of what is happening. With such a platform, city decision makers will be able to not only understand what is happening in their city, both in real time and from a historical perspective, but also understand how each of the verticals impacts the others. This is an essential aspect in city management, since cities are complex organisms where verticals do not exist in a vacuum, but interact with and affect each other. This led Ubiwhere to create the Urban Platform, which centralizes city management by aggregating data from these different verticals and making it available in a user-friendly, highly customizable platform. Here, operational teams can access real-time, geo-referenced data and spot any potential problems quickly, while taking advantage of having data from multiple sources available. For instance, if an occurrence such as a fire is detected, knowing its location and description is key to dispatch the necessary means to solve it. However, in order to do this in the most efficient manner, it is also important to know the traffic status in the routes that lead to such a location, the type of terrain, the type of construction, etc. Urban planners can also benefit from this integrated approach since they are able to view data obtained from GIS services overlaid on top of other relevant data sources they need to consider while making decisions. In both cases, users have access to analytics dashboards displaying and crossing historical data from multiple verticals. Finally, the Urban Platform also monitors high-level KPIs based on ISO 37120, an international standard aiming at the development of sustainable cities that gathers 100 indicators combined in 17 themes regarding the quality of services offered to citizens. It establishes standard criteria to measure cities' progress, driving effort into reaching the Sustainable Development Goals. These goals represent a call to action from all member countries based on global strategies that foster economic growth, encourage responsible use of natural resources, and promote sustainable urbanization practices. However, realizing this vision was not a simple task. While many cities already have some technological solutions for verticals such as smart parking, these tended to be proprietary solutions where data would be siloed in. This means that, in a lot of cases, while cities are able to improve the day-to-day operations of certain services, making them more efficient, they can be missing out on the potential use cases for data correlation. So, in order to realize this vision, the most important aspect is ensuring that the system is able to integrate with existing legacy systems for vertical applications, and also to easily adapt to be able to receive data from new sources that may appear. In order to achieve this, the Urban Platform was developed from the beginning to be a modular and flexible system, meaning that the process of developing connections, integrating any kind of data, is as easy as fast as possible. This also applies to integrating data from new verticals that may not have been present in the beginning. Moreover, cities are also becoming increasingly aware of the benefits of having solutions that are interoperable and standardized. This means they are more inclined to acquire systems that are able to communicate with external systems using a set of well-known protocols. Knowing this, it was also essential for the Urban Platform to be able to communicate with any system using standards such as FIWARE, which provides open data models that let different entities such as sensors, air quality readings or traffic measurements be represented in a standardized way, and also open standards such as NGSILD that let different systems know how to query and obtain data from one another. By implementing these standards in terms of data ingestion, the Urban Platform ensures interoperability with systems that implement them as well, meaning that no specific development is needed in order to obtain data from these systems. But this is not the only advantage in implementing these standards. It also means that the data made available by the Urban Platform can also be easily consumed by other systems, ensuring that the city is not stuck with a proprietary solution from which it cannot extract data. This lets the city build a new ecosystem around this data, which can be used to develop new services that add even more value on top of the Urban Platform.